Hello everyone, welcome you all. So in this video we are going to discuss about problems on flip-flops. So these are the problems which are generally asked in Karnataka PGCET and other competitive exams. So these are the 1 mark problems in that entrance tests. Okay, so they are somewhat tricky but they are important. Okay, so first we will solve. The first one is, how many flip-flops are required to build a shift register to store decimal 28? So we know that if you want to store something, then we need shift register. So it consists of flip-flops. So if this is a shift register, okay, so if it is a 4-bit shift register, then it has got 4 flip-flops inside it. Then only it is possible to store the 4 bits. So one flip-flop will store 1 bit here. So first bit will be stored here, then second bit here, third bit here, and fourth bit here. So binary, either it can store binary 1 or 0. So it will be storing 1 or 0 here. So one flip-flop can store maximum 1 bit, and if you want to create a 4-bit register, then we need 4 flip-flops. Okay, so 1, 2, and 3. So like this is a general structure how a shift register is built with the help of a flip-flop. So now coming to our problem, here we have a decimal value 28 and we want to store it in the shift register. So shift register means we want to build a shift register, so we need flip-flops here. So they have asked how many flip-flops are required. Okay, so first what we will do, we will convert 28 into the binary. So in binary we can write it as 11100. So this is the binary equivalent of 28, and we know that there are 5 bits in binary equivalent because 1, 2, 3, 4, and 5. So these are the 5 digits or bits in the binary equivalent. So the number of flip-flops required will be 5, because the one will be stored in first flip-flop, and again one is stored in second flip-flop, and third one is stored in third flip-flop. Then 0 is stored in another flip-flop, again 0 is stored in another flip-flop. Like this, with the help of 5 flip-flops we can create a shift register to store the decimal 28 value. So this is how. If it is a 38 value, then we need to write the binary equivalent. So if it is the value 2, then write the binary equivalent, that is 10. Then we need only 2 flip-flops because only 2 bits are there. So like this we can calculate for any decimal value by converting it to the decimal equivalent. So this is all about first problem, and coming to the second. So the problem is the delay for each flip-flop is 80 nanosecond. So they have given a delay. What will be the maximum operating frequency for mod 32 ripple counter? So they are asking for what is the maximum operating frequency of a mod 32 ripple counter. So it is counting from 0 to 32, 0 to 31. If you are considering from 0, it will be up to 31. If it is starting from 1, then it will be up to 32. So that is a ripple counter, so it will count from 0 to 31. Okay, so they are asking what is the maximum frequency is the number of output cycles per second. So a maximum frequency of the output which can be produced. Okay, so maximum frequency which can be produced is given by 1 divided by 5 into 80 nanoseconds. So the again the counter consists of flip-flops, so it will be storing. So each flip-flop has got a delay of 80 nanosecond. So I have written a 80 here because time, frequency, and time are inversely proportional to each other. We know this relation, right? So f is equal to 1 divided by t. That's why f max is equal to 1 divided by 80 nanosecond. But the question is why I have written a 5 here. So we know that if we want to write 2, then we can use only 2 bits, that is 1 0. So with the help of 2 bits we can write. If you want to write 8, we need 3 bits. Okay, if you want to write 16, then we can write it with the help of 4 bits. So up to 15 we can write with the help of 3 bits, but if you want further, then we need to use 4 bits, 16, 17 up to 32. Okay, so there we need 4 bits. 31 we need 4 bits. Then Again, if you want to write 32, then we have to use 5 bits here. So that's why I have written 5 over here. It implies the number of flip-flops. So there will be total of 5 flip-flops. Okay, so that's why we have to write 1 divided by number of flip-flops into the time of the or delay of each flip-flop in the circuit. So 1 divided by 5 into 80 nanosecond, which will give 2.5 megahertz as the maximum operating frequency of mod 32 ripple counter. So like this we can solve for any other if the delay of the flip-flop is given and the mod number of the ripple counter or any other counter is given. So like this, these are the sum of problems. I hope you like the video. Please guys hit the like button and subscribe the channel for more updates. Thank you. Thanks for watching.